Okay, we should be back for Advent of Code Day 20. Yesterday's problem was a doozy, but we did manage to get to the end. For some reason, I just encoded the rules for this wrong, it must have been, or maybe I was trying to early prune the search space too much, and then I was coming up with optimizations that were actually giving the wrong result. In discussing the problem with some other people on a couple of Discord servers, it seems like I'm pretty happy with the heuristics I came up with. It turns out to be pretty performant in still getting the right answers for these problems, but again, this question and I think 16 are still ones that I want to explore a little bit more without looking up spoilers on stuff. But anyways, we'll see what happens here for day 20. I wonder if now the virtual machine will finally come back, or if it'll be like that other year where there was like one question about it but then it never came back. There's been a lot of tricky questions this year. I would say yesterday, 17, 16, even 15 was a little non-obvious, I feel, at the part 2. So quite a few tricky problems this year, which actually surprises me, because usually there's only like 2 or 3 that I think are quite difficult. It's making for interesting challenges though. I've liked every problem so far. There hasn't been one that has made me groan. Probably gonna regret saying that, but we will see. Number should move in the mixing to mix. Move each number forward or backwards equal to the position. So it's a circular array. I don't have that data structure very handy. So that's the arrangement. They move in the initial ordering. Grove coordinates can be found looking at the 1000. Okay. So I guess we probably should just... Wait, how big is the actual input? Oh, it's pretty big. So when I never know the right moves, let's see. So you move up by 1, and then this moves up by 2. Oh, so they move in order. Okay. I should probably keep track of the individual ordering then. Help. Or we just keep track of where everything is. I don't know. This is like an awful way to do it. What's the best way to do this? Oh, it's like... So it's gonna move that many forward. Like, biggest numbers here are not that much. Probably like a linky listy question might be the easiest way to do this. What are the moves gonna be if we move it forward? You just insert it and then re-link them in the back. I feel like we're gonna need something like this for later, right? So maybe we might as well just do it now. Do this, and then also last equals n as well. Otherwise, n dot back is equal to, and then last dot forward equals first, and first dot back equals last. Is it? It's gonna be, you have to unlink it, so parent equals no dot back, child equals no dot forward. We unlink it by, so cur is equal to no dot n for in range. Oh. And we do cur equals cur dot forward. We probably could use like a skip list or something here. So we skip forward that many times, and then we have to relink things, so stitch parents back together. That seems weird. Dot forward equals child. Child dot back equals parent. Stitch move node in. So it's gonna be current dot forward is equal to. So it's where we are. Our current would be current points to this, so it becomes the next thing in current. So current dot next is equal to node, and current dot next dot back is equal to node, and node dot back is equal to cur, and cur dot next, or node dot next, or forward is equal to cur dot next, right? So let's try this. Great, and then let's try to advance the first node by 1. Oh, of course that won't work. Cur is equal to, it'll be position 1, I guess. Should have shifted it over. Cur is equal to oh, it's just I called it the wrong thing. This is gonna confuse me. I need to do this. We aren't setting the correctly node. Yeah, that seems right. And so these are what we came from, 2 and 4, so we have to put them together. Oh, I guess we're supposed to do it at the very end. We just have to track what the nodes are. Maybe we do this after that. That's 4-2. That should be correct. 2 minus 3. That's correct. So we set that there next to point to the node. Oh, I have to do them in this order. Why are linked lists so hard? Okay, 21333204. Okay. It's gonna be, we want to advance node 0 by exactly n, which is the value of it, and then look at the 1000th number after 0. Okay. Okay. We're gonna say cur equals cur.next, and then we're gonna say vals.append current.val, right? And then we're gonna sum vals. Wait. What do you want from me? Line 66? This cannot be interpreted as an integer. Why are you a list? Huh? I thought I said none of that. Oh, I didn't do that here. Okay. I think it's 4 to 0. Am I supposed to? Let's see, if I advance 1, we would go forward that many times. We should probably check this. So and then one oh my goodness. So we start like this and we get 2, 1, that seems fine, and then we move the 2, so the 2 moves between, shouldn't the 2 have moved, wait, oh we didn't move here, and then 2 should move this way. Why did the 2 move over here, huh? The 2 definitely should have moved up by 2. I mean, at least the list stays together, which is good. So here, the current is -3, which is correct. It should be stitching minus. Oh. Okay, does the state look right? One. So we're 1, -3, 2, that looks right. 1, 2, 3, -2. Oh. We just 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Where did our -3 go? Hello? It just disappeared. We lost it. Oh. Or it's probably easier to just do it this way. You compute if n is less than 0. So this is equivalent to length of positions minus what's the actual offset? If we're moving this guy by -3, we're moving it by 1, 2, 3. 1, 2, 3. Because we have 7 things, so it should be the length minus n minus 1. Because it's 7 minus 3 minus 1. We should have 3. Okay, maybe not -1. Does this look right? 1, 2, -3. Not quite. Oh, I guess if it's -3, we just do it twice. Right? Or we just do one extra. Oh, no, I just didn't... Did I even do this properly? -3 is supposed to move... Okay, we moved 1 too far, right? So... And then you do 1 extra, like that. Whoops. Is the end state right? Oh no, now we lost our 0. Why are lists so hard to deal with? I feel like this isn't actually even working correctly. -3. Okay, so it works things moving forward, right? It's just moving backwards is wrong. Here we should have moved one more backwards, which is fine. That's why I think this should be here. So if this is the state, which looks right, here we move 1, 2, 3. Shouldn't we always be looking? It's ahead of, it's the one where we want to move it into, right? So here if we want to move 3, 1, 2, 3, we look at the 0 because we want to be between the 0 and the 4. Oh no, this is right, okay. And then we want to move the -2. So the current should be 4, so this is right. Okay, and then move the 0. Oh, I guess we can just do this. -3, 4, 0, 3, -2. Yeah, okay, great. And oh, we have to find the value 0. Okay. If and then it's we started at good. Okay, so that's 3, and then this is oh, this is printing too much. Interesting. Interesting to get this wrong here. Because I am pretty sure like we end up with everything correct here. 1, 2, -3, 0, 3, 4, -2. We didn't move anything. 1, 2. Is this a case of works on classic case of works on the sample but not on the real input? They won't let me resubmit the same wrong answer, right? Yeah. What could it be? Let's think about this a little. It's 5,000 lines long, so we probably should just take everything mod that, right? Does mod work that way for negative numbers? I always have to continuously check. -7, mod 5. I mean, does this actually work too? We just 37. Negatives are not good. Absolute n length of pause n equals negative n. This is a different number? How do we get a different number out? Wait, if you moved... I guess we should just test this. We bring up a sublime. So if we move this one, this is our anchor point, I guess. We move it 1, 2, 3, 4, 5, 6, 7. It should appear between 3, 4, right? Which I'm pretty confident we were accurately doing before. Doesn't even seem like we need to do that math. Oh wait, this looks wrong. If we think of it occupying spots, 1, 2, 3, 4, 5, 6, 7, it should be a no-op. Right? So I think it's actually... we do this first. Moving the 7 should be a no-op. And our math for mod is wrong. This shouldn't be affecting the pre-modded stuff. Should go 1, 2, 1, and then it should be... yeah. Wait, where did our 0 go? Oh, we don't have a 0 anymore. Yeah. -3 should go between the number 2 and 0, which is correct. 3 moves between the 0 and the 4, yeah. And then the -2 goes here, the 0 doesn't shift. Yep, and then... okay, I wonder... okay, why are we failing here? Oh, because we don't have the 0 anymore. Somehow, I'm getting all these different answers. Would this have simulated the right thing before? Oh shit. Okay, this is an answer we've tried before, right? Definitely not, right? It doesn't handle this case correctly. Okay, so that's definitely why that is wrong, but now we want to make sure that we're handling cases correctly, where it's like -7. That stays the same. What if we're greater than the modulus? So this should function the same as 8, right? The 8 moves between the 2 and the -3, okay. And then -3 should function the same as -10. Yeah. Have I tried this answer before? We're getting 4 minus 32. 6664, I feel like we tried it, yeah. Oops, sorry, bumping the mic. What could it be that I didn't account for? Because this should account for this should account for all the weird circular motion and stuff. Because we definitely align with the expected movement. 1, 2, 3, minus 2, 2, 0, 4. 1, minus 3, 2, 3, minus 2, 0, 4. Is there anything suspicious about this? I mean, this all seems reasonable. I guess we should just check the -1 case to make sure something reasonable is happening here. So if this goes back -1, the -1 should be between the 0 and the 4. Yeah, so we handle all the movement properly, right? Make sure we don't drop any numbers. we are dropping a number somewhere. We're missing exactly one number. Oh boy. How are we gonna figure out what that is? Interesting. Which happens to be... oh, it's like 6. Okay, so we don't handle 6 properly. Like 1 minus the range. Probably because it overwrites the parent somehow. I see. Yeah, of course. So we need to do this sort of stuff. It's gonna say honestly, it's probably just easier to tell. This is correct, right? Okay. Feel like... really? Really, really, really? This is what I just tried, right? Yeah. 2473? Okay, we're not dropping any values anymore, which is good. We get the right answer for this, which is good. I mean, we have 5 minutes to play around with stuff. What else would this be? This would be 7, so it could be 13 as well. we started here. We moved it back between 0 and 4. Which is the same behavior as if it was -1, right? We end up with the same thing. Okay, fine. Does 5 work correctly? -2 around the array? We should be going 1, 2, 3, 4, 5. So we should be stuck between the 0 and the 4. I think that's correct. Oh, I mean, it's probably -6 that's upsetting. It's the equivalent, right? 6 would be equal to -1. No, but -1 is actually handled correctly. Like, that's the whole point. We don't move on 0. Now we're between the 0 and the 4. That seems correct. I feel like the mods are all correct too. Unless it's like -7. No, that detects correctly. -6 should be equivalent to +1. Oh. No, we're not happy with that. I see. Gotcha. So -6 is equal to negative length of position plus 1, and it's just equal to +1. Great. Okay. How much time do we have to wait? Oh wait, no, we got the same wrong answer again. That's what happened there. -6 shifted up. 4, 2. I mean, this seems right now. Let's check for other things. So -6 should be similar to -13. And -14 should be no op. Of course. Wait. I feel like we're good with all the multiples and like off by ones and stuff now, right? minus 15 is like equivalent to minus 1, so it moves between 0 and 4. That seems fine. Minus 13. Is equivalent to a minus 6, which should be a plus 1, so it should move up between 2 and minus 3, yeah? That does appear to be what's happening. But this was a wrong answer. I mean, this question really isn't that hard, or it shouldn't be. Wait, why are we 0 every... Is that just coincidence? Because I made it an even number? Zero happened. Wait, how come no movement happened there? Oh. Oh, I see. It moved here, and then the 2 zeros happened after because of the initial ordering. Right? Grr. After 11, so 1, 2, 7, 9. 5 gets to move by minus 1 is correct because it would normally go 1, 2, 3, 4. Wait. 1, 2, 3, 4. 5. Wait, is it supposed to occupy? Wait, is the mod on movement? Wait, no. No, this has to be right. It has to go here because if it was moving by 7, it would overlap, right? 1, 2, 3, 4, 5. After 1, 7, 3, 9, 11. 1. Oh. Unless that's not the correct interpretation and the mod is supposed to be like you take it out and then you move it and then you put it back. To move the number 2. It's like another interpretation, right? Before 4, before 9, 2, 3, 4, 5, 6 would bring us back, even though the list of length 7. So maybe that's actually the right interpretation. I mean, it's worth a shot, no? 0. Why are we dividing by 0, friends? If 6 rotations is actually equal to 0, let's go back to this example real quick. So that's not correct. Now let's go to this example. Uh, 143. Maybe this is the interpretation. Wow, okay, it was that the modulus was wrong. Okay. And then you mix it 10 times? Okay, great. Okay. Then we do this 10 times. And we do the same thing. Oh, whoops. Okay. Oh, so we mix it. We mix it 10 times. Got it. So it's this. So that's that, and then this is this. Is the printing that's slow? Wow. Okay. Yeah, we spent so much time on this problem, which was actually pretty straightforward, but we will go through it nonetheless. After. Okay, I wonder if I click this button too early and it's gonna override what actually got streamed, but we can jump back into this and kind of explain the problem. So, Grove positioning system. Let's get rid of the things we don't need. Yeah, this question, I think I understood it off the bat, but wrote way too buggy of an implementation. But essentially, we're given a file with a bunch of numbers in it, and we have to mix them by moving them all around. We call this encryption scheme mixing. And so what we do is we take every number in the file in the order we originally see them in, and either move it forward or backwards by the number that it is. So for example, if this is our file, it starts out in this arrangement, and we look at the 1 first. And because it's a 1, we want to move it forward 1 position. And so that changes the order of the list, right? Now the 1 is between the 2 and the -3. The next number that was originally in the list was the 2. So we have to go and find the 2 and then move it up 2 positions. So instead of being between the 4 and the 1, it's going to go whoomp whoomp and be between the -3 and 3. So we do that for every number that in the original file, and then we basically just search through the file for certain numbers. But that's not so important. The important part is how we actually represent this data. So let's do this, where we can call this a pause. We need a better name for this. We can call these we only care. We'll call these number indexes. So we'll do this, number indexes. And we need to know this, and then we also need to know where the 0th node is. So we'll rename that one from good to 0. Okay, this should be enough to get us going. So I guess the key insight on this problem is, if we look at the input and how many numbers are in it, there's like 5,000 numbers. And so unfortunately, it's not gonna cut it probably to just like maintain a list, like a strict Python list of all of these numbers and try to do the moving. Because the hard part is going to be keeping track of, for example, when this -3, after you do every move, these numbers are gonna shift around. So how do you know which number has to move next? Well, I guess you could keep track of the original ordering and say, oh, there's a -3. So now I have to go through and look for a -3. Oh, here's the -3. I'm going to move it next. Well, there's two problems with that. One, it's an O of n operation to figure out where the next thing is if you're just searching linear through this list. And B, when you what if there's duplicates of a number? You can't keep track of, well, if this one moved there or there, like which one are we actually operating on? You might consider, oh, we can alleviate that by keeping track of the position of every element rather than moving them around. But the problem with that is every time you move something, in theory, you could be updating the index of every single number in the list, and you'd have to update O of n indexes, and that is not ideal. And so the solution is actually to make a linked list of all of these numbers, and that's exactly what we do here. So we make a class, a node class, I guess. It really is just something to create this linked list out of, and we keep track of, do we even need to keep track of the, I don't even think this value is important, right? We basically, each node stores its value, so the number that it is, and also who's in front of it and who's behind it. So the reason we do that is because with a linked list, you need to be able to jump forward and backwards. So that's what we do here. We will, I'll just make this correct for part 1. We read the input on the line, we make a new node with the identifier and the number that it is as val. This is number. Let me just put in better variable names. So we also have to keep track of the start of the list and the end of the list while we're parsing, because it's a circular linked list, as the problem says here, circular. So we're going to have to point the 4s next to the 1 and the 1 back to the 4. It's a circular doubly linked list. And so if the first is none, we set it to this current node that we're looking at. Like so. Otherwise, we will take the, we will say for this current node, we will point back to the last node that we saw, right? I guess, yeah, because the first node won't have a last to point back to, we have to connect it in at the end, right? Because the last it's going to point to is actually the 4 that comes at the very end. Then we also have to keep track of a dictionary pointing to these objects in memory so that we can easily, find any given one of them. I guess that's not strictly necessary because I guess all we care about is, oh no, we do because we have to move it around. So we have to be able to jump to it in O of one time. So we keep track of where every object is keyed on the index that it originally appeared in the list of this ordering. And then we say the node that we just added becomes the tail of our list. So this is node, this should say node, this should say node. And then important thing, because we're going to need the 0 valued node to recover the grove coordinates. If num is equal to 0, then we just keep track of where the 0 node is. So we do that, and then I guess we don't even need this numbers array because we're operating completely on the linked list. So this is actually pointless. So the next insight to make is we can optimize this. A lot of these numbers are like quite large. This input is actually only of length 5,000, but there's like a lot of unnecessary stuff to do here. Like for example, if it's length 5,000, you don't actually need to move something around by like 8,060, right? Because at a certain point, doing that is the same as just doing something around 3,000, right? A lot of the movement would be redundant. And so let's code up how to advance a number. So given a node and the number, what do you do in a linked list? Well, first we have to do some shifty logic here where we want to do the smallest possible movements to a certain point. So if n is positive, we will take the we'll mod it by this big modulus, and the modulus is actually the length of the initial list minus 1. And this was what I struggled with on this input because the problem input doesn't give you any examples. It specifically, if you notice, leaves out the numbers 6, like -1 and like 6 and -6 and stuff like that. If we move this 2 by 1, 2, 3, 4, 5, 6, it ends up in the original spot, whereas the list is of length 7. So the magic number here is actually 6 to avoid doing something cyclic or like the periodic behavior of moving items rather than the length of the list itself. So it's actually length of list -1. So we do some correction here to avoid doing extra work. And then I don't even know if this was strictly necessary. Maybe this bug existed because of the original mod that I was choosing. But nonetheless, we say, oh, if we were close to the original mod +1, wait. If n is equal to mod +1, n is just equal to 1, well, I guess this never happens anymore, right? Because we're always just going to be dividing it by the mod. So yeah, I do think, oopsies, I do think this is strictly unnecessary now. So now we do the work of keep track of old parent child. So now we do the work of actually moving it. So let's do this. For example, let's move the 1. So what do we need to do to actually move the 1 in a doubly linked list? Well, the 1 has a pointer forward to the 2, backwards to the 4. The 4 has a pointer to the 1, the 2 has a pointer to the 1, and we want to move it here. So that looks like this. In this scenario, the 1 now points back and forward to 2 and -3. These outside things point into the 1, and then we have to re-stitch together the 2 and the 4. So 2 now connects to 4, when before they were only connected through means of 1. So we basically do that work here. We keep track of the parent, which is 4, and the child, which is 2, and we say we're currently at node whatever we are, we're the 1 node, and based on what n is, we advance a pointer forward to skip ahead by the correct amount. Then we basically do a bunch of math to figure out what the next connection should be. So the first step is to, now that the 1 lives here, we want to connect in the -3 to the 1 and the 2 to the 1. So that's going to be this work here, and the 1 to itself, vice versa. So I think this is actually not necessary. I think we can just do cur.next.back. Oh no, it's okay. I'm using desc to represent this node here. And of course cur at this point points to the 2. So this operation works to move this in, and then finally we have to put together the old parent and child together. So gluing together back this 4 and this 2 so that they point to each other and we don't have a breakage in the linked list chain. So that is the algorithm for how to advance a node by n. Now all we have to do is mix all the items. So starting, this is kind of why we needed the original list of the nodes in their original ordering. We will go through every item in this index list and advance it by that given amount, right, of itself. So the 1 starts first and it goes advances by 1, and then 2 goes and advances by 2, etc., etc. Let's see, initial assist, do we need this anymore? Current is, I think this is unnecessary now too. I think all of that stuff was just debugging stuff. This is numbers IDX. Oh no, it's number IDX, like that. And pause change to, oh, this is just number IDX of val, right? Yeah. So now all we have to do is start at the 0th node, and then we jump forward 1,000, 2,000, and 3,000 numbers in the circular array, and then we read off the numbers and add them. That's kind of all there is to it. So that's basically what this is doing. So print, so part 1 is just going to be the sum of all of those numbers. Pretty straightforward, like that. If we run it on the full input, we get 14888. So part 2 says from this input, you actually have to decrypt it or whatever by applying the decryption key, which means you times every number by this huge amount. So I guess we already optimized for part 2 by taking the mod of these huge numbers. So pretty simple, right? You just have to times the values that you're adding in here. So this is going to be times decryption key once we go and add them into the arrays. But of course, this won't even do anything to make the problem harder when we're advancing nodes, because we're already taking the mod to remove this redundant work. And then it also says we have to mix 10 times instead of just 1. So great, that's fine. For that in range 10, oops, we will mix. And that is the exact same thing as before. We start at the 0th number and jump forward 1,000, 2,000, 3,000, and sum the numbers together. So if we do that, we can run it on the real input. It takes a tiny bit of time, but spits out the output relatively quickly. So yeah, pretty straightforward problem. I think I got really tripped up by taking the wrong mod. I don't know why the behavior seemed to be correct. Oh, I tricked myself. This logic here to like hard code things that were -1 or +1 from the mod was actually distracting me from the real problem, which was that I was taking the wrong mod. I'm kind of scared to look at the numbers for today. Oh, that's like kind of surprising. I would have assumed a ton more people would have solved it because I took way longer on this problem than I would say, uh, for example, day 19. This is a much more straightforward problem to solve, and I just completely wrote a buggy implementation, I think, compared to day 19, where this was very non-trivial if um, you didn't think enough about how to prune states versus, well, maybe this is hard because people aren't familiar with like the linked list question, and we're trying to do it with some other data structure. But yeah, anyways, I think this will be the last stream of the month, unfortunately, because I am heading back to Vancouver for the holidays, like I mentioned. So I will do my best to record my attempts, but I don't think there will be any more live streams. But yeah, it's been a fun month. Hoping to still get some points in the last 5 days. I really hope so, because we are falling off of the top 100. We are just hanging in there. We are 91st. um, people are gonna surpass if I don't get any points. So, um, anyways, yeah.